Hello everyone. In this video, we are going to talk about integration, and we would start with sigma notation, which is a worksheet about section 5.1 of the Calc 1, especially biocalculus. Um, as a review, you may have seen sigma notation before. We have a review here. We write sigma as a symbol to describe a pattern of addition. So it is a general sigma expression that you see here. And when we have a sub I, it means I is the counter and it changes from somewhere that is written here all the way to the last one, which usually is written here. As you see here, I is changing from 1 to 4. So when we have I as the first one, that would be 1 plus the second one plus the third one plus the fourth one. And in this case, I is the same as the counter. Sometimes we have an expression inside the sigma notation, as you see here. So it says that find the sum of the expression 2i plus 1 when I changes from 1 to 5. So we would rewrite the expression 5 times, first one, second one, third one, fourth one, and fifth one. And then instead of I, we would replace the number. So this one here, all the way to the last one, and you would calculate the sum. Let's say we have I squared when I changes from 1 to 4. So for the first one, we have I as 1, but since it is squared, you would write it as 1 squared. For the second one, you have 2 squared, 3 squared, 4 squared, and when you add them up, you get 30. If you have 3, just a number inside the sigma, and when I changes from 1 to 6 here, it means that you would write 3 6 times and you would add them up. This is why you may combine them together as 3 times 6 here. So as a general formula, when we have I or I squared or I cubed, we have found these formulas and we will use them in finding Riemann summation of the integral. So it's a good idea if you memorize these, this one, and this one. And as some common properties for sigma, we would see that when we have sum or sigma of C, which is a number, a constant here, when I changes from 1 to n is the same as multiplying C and n, or if we have a number next to a sub I which is the common term here, since C is not related to the counter which is I here, you can bring this out as you see here. Or if you have sigma of two different common terms that are added together, you may write the first one, the sigma of the first one, plus the sigma of the second one, as you see in the examples here. Let's do the examples based on the formulas that we had. For the first one, if we want to find the sum of numbers from 1 to 100 using sigmas, it means that you are adding 1, 2, all the way to 100 together. So if we rewrite it or combine them together and write it as a math formula, we would write the sigma of I, that I starts from 1 ending 100. Going back to the previous formulas, we had the formula as n times n plus 1 over 2 for this kind of sigma. But n here is 100 times 101 divided by 2. which we can simplify 2 and 100 here, and we get 5050 as the sum of numbers from 1 to 100. Next one is the sum of square of numbers. So it means that you have 1 squared, 2 squared, all the way to 25 squared. And the formula for that, let's see what if we want to write it as sigma. If we want to write it as sigma, these are numbers squared that start from 1 and ending 25. Following the formula that said n, which is 25 here, times n plus 1, which is 26 here, times 2 times n plus 1, which is 51 here, over 6. And you can simplify, and after using calculator, you would get 5525 as the sum here. For the third one, we have cube of numbers and we want to add them up. So we start from 1 cube, 2 cube, all the way to 8 cube. And if we want to write it in sigma, we would write I cubed, that I starts from 1 to 8. And using the formula that says n, which is 8 here, times n plus 1, 9, over 2, all squared. And this part will be 1296. Number 4 is about finding the sum of numbers from 1 to n plus 1. So we are going to add 1, 2, all the way to n plus 1. So the last number here is n plus 1. It is the same as adding the numbers from 1 to n because we have all these numbers and they are added together. So again, following the formula says the last one, which is n plus 1 in here, last one plus 1, which means n plus 1 over 2. So altogether, if you simplify, you would get n plus 1 times n plus 2 over 2, which means n squared plus 3n plus 2 over 2. Number 5 is about expanding. Let's say we have the sigma and we are going to say what it means. So when it says I equals 1 to n, it means I changes starting 1 to 5. So it will be the f of x. For the first one, 1 minus 1. F of x. For the second one, 2 minus 1. Next one, 3 minus 1. Next one, 4 minus 1. And the last one, which is 5 minus 1. So we would rewrite it as x, f of x sub 0, f of x sub 1, f of x sub 2, f of x sub 3, and f of x sub 4 here. Next part is this question. Please read the question, pause the video, and then listen to the solution. For part A, or the first part, we would say that since f is increasing, as you see in the graph, we can obtain a lower estimate by using left endpoints. And we know how to use 4 rectangles. In order to have that, we are going to find delta x, which means b minus a over n. So b here is 8, a here is 0 over n is 4, which means delta x is 2. So starting the first one, which is 0, we would add delta x. So which is x sub 1 will be 2. X sub 2 will be adding 2 to the previous one, which is 4. X sub 3 adding 2 to the previous one, which is 6. And the last one, x sub 3, which is adding 2 to the previous one. Oh, okay. This will be 4, which is 8. But since we are talking about lower estimate, and since this graph is increasing, lower estimate is going to be using left endpoint, so we don't use this one here. L sub 4 will be the sigma of f of x sub I minus 1 dx, not dx, delta x, when I changes from 1 to 4. So L sub 4 will be f of x sub 0 times delta x plus f of x sub 1 delta x plus f of x sub 2 delta x and plus f of x sub 3 delta x. We know that delta x is in common, so we can factor it out and write f of x sub 0, which is 0, f of x sub 1, which is 2, f of x sub 2, which is 4, and f of x sub 3, which is 6 here. Now, delta x is 2. F of 0 is this one. This is 0, and you connect it to the graph, you get 2 here. For 2, this one is 2, and you connect it is somewhere close to 4. Let's say it is 3.75. For 4, this is exactly 5. And for 6, which is here, is close to 6. Let's say 5.75. And using calculator, you get 33 as the answer here. Next part is about finding the same area using upper estimate. So for using upper estimate, we would use the last one, but we are not going to use the first one. Delta x just is the same. And for the formula, we would have R4 instead of L4. And in the definition, that would be just I. So it starts from 1. These will change. And of course, the numbers change. So we start from x sub 1, 2, 3, 4. And that will be 2, 4, 6, 8. For 2, we had 3.75. For 4, we had 5. Next one, 5.75. And 8 will be this number here, which is 6. So altogether, using calculator, you would get 41. And by comparing R sub 1 and L sub 1, R sub 4 and L sub 4, which are on a lower estimate and upper estimate, we have added just f of 8 times 2, because delta x is multiplied to that, and subtracted f of 0 times 2 for the first one. Okay, let's move on to the number 7. This is number 7. We are going to use 6 rectangles to find the estimate of each type of the area under this graph, which is a decreasing graph, which is kind of different, from 0 to 12. And for the first part, we are going to find L sub 6. So as before, we are going to find delta x, which is b 12 here minus a 0 here over n, which is 6 here. So 12 over 6 is 2. And the points will start from 0 and then adding 2 to the previous one, adding 2 to the previous one. So x3 will be 6, next one will be 8, next one will be 10, and the last one will be 12. Now, for the first part, it says sample points are left endpoints, which we call it L sub 6. You know that the definition is f of x sub I minus 1 because we are going to use left endpoints dx. And I is going to be 1 to 6. And instead of dx, we write delta x. Okay, L6 will be f of x sub 0 for the first one, f of x sub 1, sub 2, 3, 4, and f of x sub 5. And we know that delta x is in common, so I would factor out delta x here. We know that delta x is just 2, f of 0, 2, 4, 6, 8, and 10, because we are going to use left endpoints. And those numbers will be using this graph. I would write the amounts approximately. You may change it somehow. 8.8 I found plus 8.2, 7.3, 5.9, and 4.1. Altogether, we would have 86.6. Now let's do the next one, which is using right endpoints. For using right endpoints, we are going to use the points from 1 to 8 as we had before. So, sorry, 1 to 6 as we had before. Delta x is just the same. And we are going to use the trick that we said before. It's optional. You may use the numbers as we did before, but it's a good idea if we see this once. So for finding R sub 6, which means we are going to find the sigma of f of x sub I delta x when I starts from 1 and then 6. So we know that the difference here is we are going to use L sub 6, but we are going to add the last one, which is 2, because delta x is 2 times f of the last one, which is 12, minus f of this first one, because we don't use the first one, but we do use the last one. So we are going to subtract the first one and add the last one. This is another way of doing this, but you may use the points as before. So the last one, L6, was 86.6 plus 2 times 12, which is 2 because the f of 12 is 1, minus 2 times 9 because f of 0 is 9, and it will be 70.6. We expect that R sub 1 will be overestimating and L sub whatever it is, 6, 8, whatever, will be underestimating because L is related to left endpoints, usually underestimating. R is related to right endpoints, usually overestimating. But the point is, this function is not increasing. The function that we worked on is a decreasing function. So you see that for decreasing functions, as we found in the first part, L sub 6 is 86.6, which is more than R sub 6, which is 70.6. So pay attention if we have decreasing, and if we have increasing, overestimating, underestimating will change. About M sub 6, which is using the midpoints, the definition says it will be the sigma of f of x sub I star, this is the notation that the book uses, I plus from 1 to 6. So we know that we are going to use delta x times the middle points. So between 0 and 2 here, the middle point is 1. Between these two is 3, 5, 7, 9, and 11. So we are going to use these red numbers in order to use midpoint formula. So we would use f of 1, f of 3, f of 5, f of 7, f of 9, and f of 11. Again, using the graph on the previous page, we would find the amounts of these functions, or delta x, which is 2 times, the values are approximately, you may use them somehow different. 7.8, 6.6, 5.1, and 2.8, and then using calculator, we would have 79.4. So this is exactly between 70.6 R sub 6 and 86.6, which was L sub 6. And now we're going to answer the questions. The first question is asking, is L sub 6 an underestimate or overestimate? We know that since the function is decreasing, L sub 6 will be overestimating. Part C, is R sub 6 an underestimate or overestimate of the true area? Again, since f is decreasing, we obtain the underestimate by R sub 6. Which of the numbers L sub 6, R sub 6, or M sub 6 gives the best estimate? And explain. We know that M sub 6 gives the best estimate because the area of each rectangle appears to be closer to the true area than the overestimate or underestimate in L sub 6 or R sub 6. So usually using midpoints is the best estimate. Number 8. Estimate the area under the graph of square root of x. So from the beginning chapters, we know that we should know the graphs, the basic graphs. So in here, we are going to use we are going to use square root of x from 0 to 4. And we know that for 4, we have the y value of 2 because it is square root of x. And we are going to use rectangles, right endpoints, for right endpoints and 4 rectangles. 4 is here. So n is 4. Delta x will be b, which is 4 here, minus a, which is 0, over n, which is 4. And the points will be starting 0, and next one will be adding delta x to the previous one, which is 1. So the next one will be 2 and 3, and the last one is 4, depending on using right endpoint, left endpoint. We are going to use part of it, not all of it. In here, the question is asking, for the first part, is asking to use right endpoint. So in order to use the right endpoint, since the graph is increasing, we are not going to use the first one, and we use number 1, 2, 4. So R sub 4 will be the sigma of f of x sub I delta x. I starts from 1 to 4. So we know that we are going to factor out delta x. It will be f of 1, f of 2, f of 3, and f of 4. Delta x is 1, and f of 1 will be using the graph. If you have 1, square root of 1 is just 1, so 1. Next one is square root of 2, square root of 3, and square root of 4, which is 2. So using calculator, you would have 6.1463 as an overestimate because it is increasing. Part B with the same graph. For part B, using left endpoint, we are going to use the first one, not the last one. And also, we are going to use the same delta x as you see here, but this one will be different. So let's correct all these. Okay. Let's move it somehow. This is not for, okay, I can write it like this. Okay. So it will be I minus 1. I will write it as the red, the ones that change. So it starts with f of 0 and then f of 1, 2, and 3. The amounts are here. F of 0 is 0, f of 1 is 1, f of 2 is square root of 2, and f of 3 is the square root of 3. So approximately you will have 4.1463 as underestimating. Let's move on to number 9. Pause the video, read the question, and then listen to the answer. Okay, for the first one, we are going to use L sub 5, which is delta x, which delta x is the distance between all these that you see here, which are all 12, times the velocity. So for the first one, you have 30 because we are using left endpoint. And then we don't use the last one. 30 plus 28. 25 plus 22. And the last one here, 24. which will be 1548 feet. For part B, using velocity at the end of the time period, it means that you are going to find r sub 5, which will be again delta x, which is 12, and you wouldn't use the first one, but you use the last one. So starting 28, 25, 22, 24, and 27 here. Or you may subtract the first one from L sub 5 and add the last one. This is another option. 1512 feet. Part C is asking, are your estimates in part A and B upper and lower estimates? What do you think? The first one is 1548, the second one is 1512. The estimates here is neither lower or upper estimates, because if you take a look at V, it goes down, 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 and then up, and then up. So it is neither increasing nor decreasing. So we cannot say that we are going, we had overestimation or underestimation here. Okay, number 10. Please pause the video, read the question, and listen to the answer. Part A, let's say we have f of t, which is 3 over 5 f of t, according to the question, the previous page. And since t is negative t times t minus 21 times t plus 1, it will be negative 3 over 5 times t minus 21 times t plus 1. And delta t here is 2, according to the question. So when delta t is 2, and we know that delta t is equal to b minus a, which is 12 minus 0 over n, which is 6 here, over n, and we are going to find n. So we know that a number that 12 is divided by that number, we get 2 is 6. Now, having n and having delta t, we have the intervals. It starts from 0, and adding delta t to it, it will be the first interval. The next one will be 2 and 4, 4 and 6, 6 and 8, 8 and 10, and the last one, 10 and 12. For the first one, it says using midpoints. So the midpoint here will be 1, 3, 5, 7, 11, 9, and 11. So for finding m sub 6, we are going to multiply delta t, which is 2, to f of the first midpoint, which is 1, f of the second midpoint, all the way to the last one. These are not lowercase f. These should be uppercase f, because we have a definition here. And the amounts of them using the formula, this formula, you would use calculator and you're going to finding this way. Using this calculator, putting t as 1, then 3, then 5, and all the way to 11. These are the numbers that you get. 2 times 24, 129.6. So again, the first one is 24 plus 129.6 plus 288 plus 470.4 plus 648, and the last one 792, and approximately it will be 4704. These are the number of infected cells per milliliters times day. So infected cells per milliliter times days. Part B is saying that if 4,000 cells per milliliter times days is the total burden of infection required to develop symptoms, use subintervals of width 2 days and their midpoint to estimate the day when symptoms will appear. So if the threshold is 4,000, we are going to find it step by step. We can compute the total amount of infection on increasingly larger intervals, just optional, until you see 4,000. So you may use any number, but I would use 0 and 6. Using 0 and 6, n will be 3. And m sub 3 will be 2 times f of 1 plus 2 times f of 3 plus 2 times f of 5 because of n equals 3. And the number, as we talked before, we have the amounts here, like 1 here, 3 here, 5 here. We can use these numbers. And using calculator, you get 883.2. So this number is way less than 4,000. We would increase the interval in order to get 4,000 or more. So let's find 0 and 8. You can jump to 0 and 10 or whatever. So this one, n will be 4. We are going to calculate m4, and we are going to use the other method because there are a lot of numbers here. For m4, we know that we are going to use m3, and we would use one more. It means 2 and f of 7. Because after 5, we have 7. So we would add the previous amount with the new amount, as is f of 7, as you see here. So this will be 1824, almost half of the amount that we want. Next one can be 0 and 10. N is 5 here. And we are going to use m sub 5. It means that you are going to use m sub 4 plus one more. In here, 2f of 11. So the previous amount, which is 1824 plus 2 times f of 9 that we have here, 648. Altogether, 3,120, which is still less than 4,000. We would continue to 0 and 12. In this case, n will be 6, and m sub 6 means the previous one plus the new one. Oh, I'm sorry. This one is 9 because one more. We used 7 and then 9 for m sub 5, and now f of 11. So we're going to use the previous number plus the new number, which is f of 11, 792, altogether 4,505. So this is where we can see the symptoms. So as an interpretation, we would say that the total amount of infection is greater than 4,000 cells per milliliter times day, as expected, by 12 days, because we use the interval of 0 and 12. So symptoms will appear approximately on the 12th day. Okay, and the last one, which is number 11 here, is about using the definition to find an expression for the area under the graph of f as a limit. Do not evaluate the limit. So we're going to use just the limit. First of all, delta x. What is delta x? Here, it is between 4 and 7. So we have 7 minus 4 over n, and since it is about using the definition, we don't have any amount for n. X sub I is usually starting the first one plus multiples of delta x, I times delta x. In here, we have 4 plus I times 3 over n because delta x is 3 over n. So the definition says the area will be the limit when n is approaching infinity of sigma of f of x sub I delta x when I changes from 1 to n. It means that you would have the limit when n is approaching infinity of the sigma of I equals 1 to n. F of x sub I is whatever you have for x sub I plugged into f of x. So we have 4 plus I times 3 over n all squared plus square root of 1 plus 2 times 4 plus I 3 over n, as we have for x sub I squared. And it said no evaluation, so this is the answer.